Now we're going to continue with our analysis of rotational motion. First thing, let's just look at the basic angles. So here, starting off at 0, you notice the ladybug is pointing to the right along the positive x-axis. And if we go to 90, you see the ladybug at the point vertically. And let's just make the full cycle. So then 180. And then 270. And 360. Okay. So that's the first part, just the angles traveled. But now we're going to look at the rate at which the wheel rotates. So let's just, and that's going to be called the angular velocity. So let's increase angular velocity. So let's say, for example, let's go back, just reset this, and we'll have a specific value. So let's say that the angular velocity is 90 degrees per second. So that means that each second this ladybug rotates over 90 degrees. And let's go and do this, make this 180 degrees per second. So now each second the ladybug travels 180 degrees. And let's do one more. Let's go to 360. So if you notice there, each second the ladybug makes one full cycle. The other thing to notice here is that the velocity of the ladybug is always perpendicular to the radius of the circle. So no matter how the ladybug moves, so let's reset. Let's put the ladybug at the edge over here. So whatever the angular velocity, the velocity is always perpendicular. The linear velocity is always perpendicular to the radius of the circle. So as you increase the rotational speed, you still notice that the velocity is always going to be perpendicular to the radius of the circle.